pH calculations. I'm Mr. B. The pH scale ranges from 0 to 14, where a pH of 0 to 6 represents solutions that are acidic. pH values ranging from 8 to 14 represent solutions that are basic or alkaline. A pH of 7 represents solutions that are neutral. pH stands for the power of hydrogen. The pH of a solution is a measure of the molar concentration of hydrogen ions, or H+, in the solution. In this lesson, consider H+ to represent an acid and OH- to represent a base. Remember, Arrhenius acids release hydrogen ion, or H+, in aqueous solution, and Arrhenius bases release hydroxide ion, or OH- in aqueous solution. The following pH values represent hydrogen ion or acid concentrations versus their pH. So a pH of 0 is equal to a 1 molar solution, or 1.0 times 10 to the 0 molar solution of an acid. A pH of 2 represents a 0.01 molar, or 1.0 times 10 to the minus 2 molar solution of an acid. A pH value of 5 represents a 0.00001 molar solution, or 1.0 times 10 to the minus 5 molar solution of an acid. The pH formula and decimals. Consider the following practice problem. A solution has a hydrogen ion concentration of 0.001 molar. What is the pH of the solution? The pH may be calculated by using the pH formula, which is pH is equal to the negative log of the concentration of hydrogen ion. So the pH is equal to the negative log of 0.001 molar. This gives a pH of 3. pH and decimals. Considering the same practice problem, the pH of the solution may be calculated as follows, where the pH of a solution may also be determined by counting decimal places in the molar concentration. 0.001 molar has 3 decimal places. So the pH will be 3. This technique works as long as the concentration is in tenths. pH and scientific notation. Consider the following new practice problem. A certain solution has a hydrogen ion concentration of 1.0 times 10 to the minus 5 molar. What is the pH of the solution? pH can be calculated in 2 ways. One, as we already know, by using the pH formula, which is pH is equal to the negative log of the concentration of hydrogen ion, or by taking the absolute value of the exponent in the molar concentration. So pH is equal to negative log 1.0 times 10 to the minus 5, which is equal to 5. Or take an absolute value of the exponent, which is negative 5. This gives a pH value of 5. This technique works as long as the coefficient in the molar concentration is 1.0. pH and basic solutions. Consider the following practice problem. A certain solution has a hydroxide ion concentration of 1.0 times 10 to the minus 5 molar. What is the pH of the solution? In this case, we must find POH first, where the POH is equal to the negative log of the concentration of hydroxide ion. So POH is equal to the negative log of 1.0 times 10 to the minus 5 molar. This is equal to 5. Or we may take the absolute value of the exponent. So the exponent in 1.0 times 10 to the minus 5 molar is 5. Now use the formula 14 is equal to pH plus POH. So subtract the POH value from 14 to get the pH. So 14 minus 5 is equal to 9. And the pH value of this solution will be pH 9. Comparing concentrations. It is important to remember the higher the pH value, the less acidic a solution will be. For example, compare the acidity, the H plus concentration in a solution of pH 2 to a solution of pH 3. A solution of pH 2 has an H plus or hydrogen ion concentration of 0.01 molar. A solution of pH 3 has an H plus or hydrogen ion concentration of 0.001 molar. So dividing 0.01 molar by 0.001 molar gives a factor of 10. So the pH 2 solution is 10 times more acidic than the pH 3 solution. Or we could subtract the small pH value from the large pH value. 3 minus 2 is equal to 1. Remember, each unit of pH is a factor of 10. Remember also that the larger the pH value, the less acidic a solution will be. So the solution of pH 3 is less acidic than a solution of pH 2. The pH 3 solution is 10 times less acidic than a solution of pH 2. Remember also, if a solution contains more acid than base, the solution will be acidic. If a solution contains more base than acid, the solution will be basic. And if the solution contains equal amounts of acid and base, the solution will be neutral. This concludes my explanation of how to perform pH calculations. I'm Mr. B.